Alright, Solidworks. We want to click New, File, and then Part, OK. Now we'll be put into the 3D space. We want to sketch an area on a 2D plane and then extrude that into a volume. So click Extruded Boss / base here. Then click on Top Plane, and then you'll have a 2D plane you're on. You're in a sketch right now, as you can see by the indented exit sketch here. Now you want to create a rectangle by select that corner rectangle. Click on the origin. It doesn't have to be origin, but just drag and drop here. And now go to Smart Dimension to set the length and width of that rectangle. Let's set it at 100, and the other one at 200. Oh, having trouble with the mouse. Okay, 200. And then you can also use the mouse wheel to zoom in and out. It'll zoom in and out relative to your cursor. And you can also hold Control and then click on your mouse wheel, and then you'll be able to move around relative to the image. And now we have the 100-200 rectangle. Now just quickly click Exit Sketch, and then you'll be able to extrude your area, your sketch, by whatever length you put on the side here, and say let's do 300. So right now we have a 100 by 200 by 300 rectangular prism. Then click the check mark on the left hand side, OK, and we'll have a rectangular prism. Great. Now we want to make a hole in that rectangular prism. We want to click Extruded Cut at the top here. And now we click on one of the faces to extrude cut from. Let's say the top one right here. And then we want to zoom in for a better view. Then go to rectangle, and now we want to reference one of the datum points, and we click rectangle, then click on that corner. Then we just click and click again for a rectangle, Smart Dimension, where we want the whole positioning to be. Let's say 100 here, and let's say 75 here. Just has to be arbitrary values within the rectangle face, and click on the circle. Then click on the the corner diagonally opposite to the corner of the rectangular prism we were sketching on. Okay, click again, and then click one more time for a circle. Doesn't have to. The circle we are going to change the dimensions of, so we can be arbitrary on that. And now, if you click on Smart Dimension and click the perimeter of the circle, note you have to be very good at aiming, right? And then click there. You'll set the radius of the circle at, say, 20, and it'll be like that. Click Enter. You'll have the 20 diameter circle now, and you click OK Dimension, and now you can exit your sketch, and this will be almost finishing the cut extrude. And now click on the part of the sketch that you want extruded. Click on that, and then you'll be able to see that your circle is designated for cutting. And at the side here, you'll see blind. Blind is if you want to cut a certain amount, but right now we want to go through everything, so through all here. And now we click the check mark. Remember to always click check mark or exit or cancel wherever you're in the middle of a process, otherwise you'll encounter difficulties with being able to click on any of the tool symbols right here. And now we have a rectangular prism with the hole that's going right through it. As we can see here, it goes just all the way through. And we have the part that we want. Let's export it. How we export it is we want to save as, and say we name it part 8. We want to save it to our desktop, and we save as JPG, one of the images that we can save it as. And okay, we've just exported this model as JPG. We also want to do that for 3D standard file format, the step files. So desktop again, we want to select step AP203. That's the standards of the step standards. Name it part 8 again, desktop, remember that, and save. And we got the model saved as both JPG and step. Okay, now let's make a 2D fabrication drawing out of this. We go to New, and we can do Drawing. Okay, and then we can just select the first one. It's not really important right now. We go to the right hand side here, View Palette, and we should be able to select, if we can't see it there, we want to go into our navigation bar here to select a part or assembly. And as long as you have a save there, you want to click all files. Say take our step file that we saved, and not Neo, we want the part 8 right here. Alright, we'll try part 8. But no, that we don't need step files. We need these solid part files. Not good. We want to reopen our. We want to go to the folder here. Click on the part we were working on. We need to save this, the Solidworks file, so that the Solidworks can recognize it within the 2D fabrication drawing, the interface. So you want to be in the desktop, file name part 8, and save as a Solidworks part. Save. And now once you've saved this like this, then you can open it in the drawing. Let's go back to our drawing by clicking on what's open in SolidWorks, draw 3, and this time it should pop up in the view palette, and it does, part 8. And then it'll load all the images, the 2D images. You can pull out you can drag and drop the isometric, you can drag and drop the left side, all sorts of things. Doesn't really matter right now. Important part is getting those images from the view palette onto your 2D drawing. So, and if you want to move these images, projected view. If you want to move these images, you will just have to go through the content, and it'll have a blue set of arrows like that, and then you can just move your thing around. Unfortunately, if right now the standard is your images are connected to each other, so if you encounter difficulties like that, just start erasing. Yes, and you'll be able to solve some problems like that. And okay, important part here is you've got some images on the 2D drawing. Now let's put some dimensions on it. 300, and these are all dimensions referencing from the part dimensions you put up in the part. And one more for the hole, true 10. It may look like a lower diameter, or right now it looks like it's supposed to look like an ellipse because it's referencing from a 3D view, but it's truly 10 millimeters diameter, and that's why there is true R there. And okay, once we got the images on there, we got the dimensions on there, we can save this as we can save it as a drawing, but what we're really concerned with is saving as viewable files like PDF. So we want to save it on the desktop, name it part 8, name it PDF, save, and alright, we'll be able to save it as a PDF. We also want to be able to save as standard 2D drawing formats like DXF. So after this PDF ends saving, we can also save it as a DXF.
What did you just save it as?
Just saved it as the PDF.
This one takes a while for some reason.
It's taking a while.
Can you stop here?
Oh, we forgot to go over assemblies.
You want to add assemblies into this tutorial?
Sure. Okay.
Try clicking out of it. Minimize that.
Okay, great. We're back, and we save it as a DXF this time, and it'll do that. And after this DXF finishes saving, we can view it on our desktop. It'll be one of the DXF files, part 8, and right here you can see the PDF finished, and you can also see the JPG, the image file that we saved from before, right here, like so. Okay, so let's go over assemblies, because that's important. So we know how to make parts, we know how to make 2D fabrication drawings, and we know how to export various file formats from both. And now, if we want to try making assemblies out of our little part, we can click New, and click Assembly, OK. And now, we can, oh, it already does begin assembly, but let's just cancel that. And if you want to ever insert additional components, you click Insert Components here, and if you want to insert multiple components at a time, you click this little pin here, so keep visible, and then click on whatever your part you want to open up and insert into your assembly file, and bam, your cursor will show your little part that you're going to insert into the space. Click on it, and then you could, because we've already clicked the pin here, we can do it one more time, click on it, and then we'll have our 2 of our parts. Now we're good, we click check mark, and now what an assembly is, you have multiple components inserted into the space, and you want to have a file that shows the relationship, the positioning relationship between these files. You can click with the mate button on any face, so let's say the top face here, and click on this face also. And if you do that, these will go concentric. Now if you want these to be opposing to each other, then you can click this flip mate alignment button, and it'll flip it like that, and make sure that these faces are now positioned coincident in the opposite way, and then you can click OK. And now if you want to create further mating, you can click on other faces such as like that one and this one, and it'll make a coincident like this. But you can also use different types with different styles, like if you want to have these at a distance, then you can click the distance and set it at say 50, and these two faces will be apart 50 along the normal to their planes. And you can finish it off by doing the final dimension, because we've positioned these two parts relative to each other in 2 axes. Now the third axis will be this, and we could do it another distance, and let's do again 50. And okay, and then we have two parts mated like so. And if you want to save it, we just do it normal save as.
Show some other mates, like maybe perpendicular and other faces and things like that. Like save, mount that.
Oh sure, okay. So if we want to have different styles, we can say start off by deleting the existing mates we have, because right now these parts are fully defined. Delete, yes to all. Okay, now the mates are all deleted. We can remate these parts as, say, if we want this face to be perpendicular to this face, then it'll go sideways like this. But if we click the perpendicular, it'll go back into there. So you can vary your mating based on the faces you select, and also based on the styles that you select here. So there's coincident, parallel, perpendicular, and you can also lock the components together. That means fixing them relative to each other. And then there's distance, of course, like, and then there's angle.
Show the lock.
So lock goes like this, and if you finish that and we go back to here, see that there is the lock on these two parts, which is.
How about lock, like say this face to that face?
Sure, we can do that. So we click mate, then we click these two faces, then we lock them together. But you'll get a lock based on the existing one. Based on when you do lock is not any kind of coincident thing. So first you have to make a mate like this, then you want to just select that on any of the faces and click lock, and now you can fix it from the existing state of your two parts. So lock does not actually do a mate of the component. It fixes it wherever they were originally. And that's it for the assemblies. You can save it as, you can save these assemblies also as JPGs and view it. You can also save these as step files. So as you can see, you can step it as a step file here, desktop, any name, save, and you'll be able to do that. You save it as JPG so that you can view it, and you'll be able to do that. Important part is, I'm not mentioning too much here, is you want to save it as the native Solidworks file so that you can reopen it on Solidworks with all the metadata, including the assembly. Especially for the assembly, it's important, because if you don't do that, then you'll end up with opening your step file, for instance, and your assemblies and all your mates will not be there. And if you view the JPG, oh, it seems that the computer might have frozen up.
Double click on the mouse.
Oh, okay. Technical difficulties with the mouse. Cool. So we've saved the assembly as JPG. We can try viewing it here, and ba-bam. And that's it for the parts, exporting from the parts, assemblies, and 2D fabrication drawings. That's pretty much it.